In this short video, I'd like to show you how to use the ArcRefline program on a Nikon total station. Before doing that, let's have a look at the data that's going to be used. In this simple example, I have an arc plotted between points 7 and point 8. The radius of the arc is 3 meters. One of the inputs for the ArcRefline program is the tangent bearing of the line that would enter or exit the curve. So it's worthwhile in CAD, before going out into the field, checking what the bearings of the tangents are, particularly the point at the start of the curve. Now, just for illustration purposes, I've drawn in the tangent lines for the start point or the entry point, and also the exit point. If I turn the layer on containing those tangent lines, they appear in the magenta colour on the screen. And we can see that the bearing of the tangent line at the entry point to the arc is 90 degrees. So in other words, the angle turned from north to the line is 90 degrees. And likewise for the exit tangent line, the bearing turned from north around to the line will be 270 degrees in this simple example. So knowing that information, we can start with the ArcRefline program. Other information that might be useful would be the length of the arc. So again, in a CAD program such as this one, which is Trimble Business Center, I can check the length of the arc. In this example, it is 9.425 meters. I'm now going to switch to the Nikon simulator. This simulates the functions that run on a Nikon total station. A station setup has already been performed. So now I'm going to enter the ArcRefline program by going to the Program button and selecting option number 2, which is the ArcRefline program. At this stage, I'm prompted for the point at the beginning of the arc. This can be measured by using the Measure 1 key and positioning the target at the start of the arc, or if the coordinates of the starting point are already known and keyed into the job, you can simply type in the point name or number, in this case point 7. There's the coordinates of point 7, and as we saw from Trimble Business Center, the bearing of the tangent line for point 7 is 90 degrees, which on a Nikon is entered as 90 for the degrees with a decimal point, 0 minutes, 0 seconds. Next, the arc itself is defined, and there are 3 methods for doing that. Method 1 requires that you have the coordinate, or you can measure the end point of the arc and you know the bearing of the tangent line for that exit point. The second method is to supply the radius and again the bearing of the exit tangent line. And lastly, to input the radius and length values for the arc and let the Nikon calculate the end position. In this case, we'll choose option 3, as we know the radius is 3 meters and we know the length of the arc from the query in Trimble Business Centre was 9.425 metres. So I'll enter 3 as a positive value, which will extend the arc in a clockwise direction. A negative value here would project it in an anti-clockwise direction. And the length of the arc, 9.425, enter. And now we can perform our first measurement. I'm going to measure a point that will be directly on the arc at the position being indicated here, so midway along the arc. So, as expected, the chainage from the start point, point 7, is 4.712. So the value's been rounded down to the nearest millimetre, but essentially that's half the length of the arc. The offset is 0, left or right, which is the second set of numbers, as the point measured is directly on the arc itself, and there's no change in level measured. Using the simulator, I can now change the distance measured so that the target is no longer placed exactly on the arc. If I enter a distance measurement of 13.1 meters, that should give us a target position which is 100 mil or 0.1 of a meter to the left of the arc line. So if I measure again using that information, the chainage value, or the distance from the start of the arc, is still the same, but now we have an offset of minus 0.1. In other words, the target is now being measured in a position which is 100 mil to the left of the arc reference line. Likewise, if I was to move the target so it was to the other side of the line by 100 mil and measure again, I get similar values, except the measured point now being to the right of the line, over here somewhere, then the offset is a positive number. Let's measure another point. So I'm going to measure a position which is essentially here, about a meter north from the starting point 7, which means that the chainage for such a point around the arc will be 0, but the offset should be -1, because we actually have the target 1 meter to the left of the line. So let's try that. So I'm going to change the measurement values here to affect that measurement with the simulator. In this case, I need a measurement horizontal angle of 68 degrees, 11 minutes and 55 seconds, measuring a distance of 10.770 meters. And as anticipated, we're measuring a position which reports a chainage or distance around the line of 0. So we're right at the start of the line, but we've the target positioned 1 meter to the left of the line. So of course, to stake out the arc ref line directly, we'd be looking to measure the target with an offset of 0, or as close to 0 as possible. A good tip with the ArcRefline program is to stake out the start and end points first, if at all possible, as then you'll have a good idea as to where the arc extends across the ground. If it's not possible to stake the start and the end, at least try and stake one of the points to give you a good idea of where the arc is going to go. Another way of finding the arc and staking it out is to use another of the programs on the Nikon. If I escape and exit the ArcRefline program, I can select the RDM radial program. The idea of this program is that an initial point is measured, and then the distance between that initial point and any subsequently measured point is reported. Now this is quite useful if you know the coordinates for the centre of the arc, as simply it's a case then of staking out that centre point, measuring it as the first point in the RDM radial program, and then moving the target to where you wish to stake out the arc and taking a measurement to the target. When the distance reported is the radius of the arc, then you know you have the target positioned on the arc itself. So in this example, I need to measure a point which is essentially here at the centre of the arc. So I'll go into the RDM radial program and enter my simulator values that will measure the point at the centre of the arc. If I go on to page 2, I can see that bearing information that's been entered. Click display to go back to page 1. There is my first point recorded. I can now enter the simulator measurement values for the second point. So if, for example, I was going to move the target over towards this area here, I'm not going to change the horizontal angle. I will change the distance though, and measure a second time. So now when I measure a second time, I'm getting a relative horizontal distance. So this is the horizontal distance from the first point to the second point that was measured. Now bearing in mind that the first point was the centre of the arc here, and the second point I measured was close to the arc itself over here. So we can see that I've got a horizontal distance measured of 3.050 meters. In other words, I'm 50 mil above 3 meters. If I was to reposition the target and measure again and check that horizontal distance value, as soon as that displays 3 meters, then you know that the target is positioned at the radius distance that you're looking for, and the ground can be marked accordingly. So I'll just take another measurement with the simulator. The measurement is taken. The horizontal distance is now exactly 3 meters from point 1. So I now know that the target is positioned on the radius of the arc and can be marked. Thank you for watching this video. If you have any questions or comments or require any training regarding Nikon total stations, including setting out and the ArcRefline program, please get in touch with us via the correctgroup.com website.